So this particular question comes from Megan. She's saying, I'm having the hardest time figuring out how to write an equation given the y-intercept and another point. So given the y-intercept and another point. The question she's asking is, how do I write the equation? And there's a sub-question in here also. I understand the concept, she says, but it's understanding when the rise and the run are negative, which point do you start at, and should you rise first and then run? So we'll look at an example when both the rise and the run are negative. Where do I start? So that's the question. Let me come up with a problem that we can use to illustrate the solution to this question. So the problem might be, write an equation for the line whose y-intercept is, let's say, 0, -3. And the line which passes through another given point. Let's say that the line that it passes through is -2, -11. So this is an example of a question that's similar to the one that she's asking about here. We're given the y-intercept of a line, and we're given another point on this line, and we're asked to write an equation for the line that contains that y-intercept and that other point. Let's quickly just draw a sketch of what this line might look like, just so that we have a little consistency check on ourselves as we go forward with its solution. So on an xy set of axes, let's mark out the y-intercept that we know. It's at 0, -2, so it's right about there. And then the other point that we happen to know on this line is -2, -11. So I'm going to mark that 3, 4, 5, 6, 7, 8, 9, 10, 11 down here somewhere. -2, -11. And so the line that we're talking about in this problem is, roughly speaking, this one that passes through those 2 points. So we just want to find an equation for that line, and how do we do it? So as with any question when we're finding an equation for a line, the very first thing that we want to do is compute the slope of this line. And the great thing about computing the slope of the line is that as soon as we know the slope, we already happen to know the y-intercept for this line. And so quickly looking at what the end game is going to look like, the end game is going to be that we're just going to be able to slot those two pieces of information into the slope-intercept form of an equation for a line. Specifically, we know we're going to be able to put it into y equals mx plus b format, where m here is the slope that we're about to find, and b is the y-intercept. And since we happen already to know the y-intercept, I'm going to fill that in right away. We know in this example, because it was given directly to us in the problem, the y-intercept is -3. So we're just going to throw that right into the problem. And I'm sorry, I think I labeled this point wrong on the graph. -3. There we go. Okay, so as soon as we find out what the slope is, we're going to more or less be done. We just have to drop that slope into the m slot of the mx plus b format. So let's compute the slope. We know always that the slope of a line joining 2 points is the ratio of the rise, in other words, the vertical difference between those 2 points, to the run, the horizontal difference between those 2 points. And each of those are quantities we can compute if we know the x and y coordinates of the points that are involved. So let's look at the rise as an example. I want to know what is the difference between the y coordinates, which if you prefer formulas written out using variable lingo, we usually think of this as the difference in the y coordinates, y2 minus y1. And if we think of our second point here, -2, -11, as the x2, y2, So let's think of this as x2, y2. And we think of our first point as x1 and y1. Then doing y2 minus y1 is going to give us, so we're going to start with negative 11. And then we're going to subtract negative 3. And just quickly simplifying that across, negative 11 minus negative 3 is the same as negative 11 plus 3. That's going to be negative 8. And one way to think about what that negative 8 means is it's measuring the vertical difference that connects the first point to the second point in this example. So in other words, to go from the y-intercept point 0, negative 3 down to the other point that we happen to know, that is a drop of 8 units. In other words, we went down 8 units to go from that first point to that second point. So there we have the rise. Let's talk about the run. That's the difference in the x-coordinates, x2 minus x1. And as usual, I'm going to give you the caveat that it doesn't matter which of the 2 points you choose to be your x1, y1, and which one is your x2, y2. If both the numerator and denominator of your fraction are reversed, then you're just going to get the same slope out the end, because the slope doesn't care. The fraction doesn't care if the numerator and denominator are both positive versus both negative. As long as the absolute values of those are the same, you're going to get the same result. So that may be a partial answer to what the questioner is looking for here. But if we do this subtraction, x2 minus x1, and do negative 2 minus 0, that's going to give me negative 2. And again, a way to interpret that number, negative 2, is that is the horizontal difference that's required to go from our first point to our second point, from the pink point to the blue point in this example. And since it's minus, that really does denote that we're moving to the left by 2. So there's where your negative 2 comes in. And so when we look at what this slope is telling us about the rise and the run that connects the 2 points that we happen to know, it's telling us that we can get from one point on this line to another by going down 8 and by going to the left by 2. And that's certainly true. Just looking at the picture that's over here at the lower left, to go from the point that's on the y-axis to the other point that we knew here, we moved down and to the left, right? On the other hand, if we had made the other choice, if we had turned the first point and the second point around and looked at it as our y-intercept being x2, y2, and our other point being x1, y1, let's just think quickly about what would happen in that example. Well, if we had it reversed, then what would happen is that both of the terms on top of this slope would trade places. We'd get negative 3 minus negative 11. Both of the terms in the denominator would trade places, so we'd get 0 minus negative 2. And in that example, when we did all of this subtraction, negative 3 minus negative 11 is going to be positive 8 now. 0 minus negative 2 is going to be positive 2. And now both the numerator and denominator are positive. And if they're both positive, that means that this rise is really a movement upwards. And it means that this run is really a movement to the right. And that's the case merely because in that instance, what we're doing is we're thinking instead of moving from the point on the right to the point on the left, we're moving from the point on the left to the point on the right, which makes us go upwards and to the right rather than downwards and to the left. But that's the thing about the slope, is we still haven't finished this computation. If we finish this computation, dividing negative 8 by negative 2 is going to give me positive 4. On the other hand, dividing positive 8 by positive 2 is also going to give me positive 4. So hopefully this is an answer to the question, what happens when both the rise and the run are negative versus when they're both positive? Well, the answer is we end up with the same result either way, right? As long as we are consistent about what we do, right? As long as we remember that having both of them negative means moving down and to the left versus having both of them positive means moving up and to the right, depending on which of our 2 points we choose to be our x1, y1 and which one we choose to be our x2, y2, we're going to get the same line and the same equation once we drop that m into our mx plus b format. So it doesn't matter. Which point do you start at? It doesn't matter. If we started at the y-intercept, then moving to the second point that we knew would be a movement downwards and to the left, which in slope form, because we'd be dividing two negatives, would still give us a positive slope. On the other hand, if we started at the other point, -2, -11, and we knew that we wanted to move upwards and to the right, then if we do that, we would end up at the y-intercept. Having moved up and to the right still gives us a positive slope. So that's the beautiful thing about slope, is that it really doesn't matter which order you subtract your points in as long as you're consistent, right? As long as you're always choosing the x2 and the y2 from the same ordered pair, and the x1 and the y1 from the same ordered pair as one another. So as long as you are consistent about which way you subtract, you'll always end up with the same slope, because any negative signs that you introduce in the process are going to go away. Another way to think about it is that what we have here is a line that slopes upward. In calculus, we call that an increasing line. And if you have an increasing line, it means that however x and y change, they change in the same direction. So if x increases, y also increases. In other words, if we move to the right, we also move up. But if x and y change in the same direction, that also means if x decreases, y also decreases. So if we move to the left on this graph, we also have to move down. But both of those are descriptions of the very same phenomenon. Whether we're talking about going down and to the left or whether we're talking about going up and to the right does not matter to the slope. The slope is always going to be the same as long as you divide in a consistent fashion. So Megan, I hope that answers your question.